Good evening. Thanks for coming. Say good evening back. It's perfect. We'll sit. The lady that is sitting here on my right is a genius, and I've had the great pleasure of. This is odd. The great pleasure of working with her on a show called Good Eats, where she acted as the science officer for the last, 20 episodes that we did probably. And I've been waiting for this book to come out now for approximately 5 years.
Yeah, maybe 6 even.
What were you doing? Because we needed it, and we need it very badly. Does everybody here have a copy? Because if anybody leaves without one tonight, you're a flavor loser. You don't want that on your head. I have been wanting this book for a very, very long time because it has stuff in it that I need. And most of the questions that I have here tonight are specifically selfish. They're just things I want to know, and you're going to have to listen, and then you can ask your own questions. So some of you may already know Arielle Dr. Johnson. By her resume, which is pretty considerable. She got her PhD from UC Davis, which is a pretty highfalutin school there. What was your dissertation?
Flavor chemistry and gastronomy, analytical sensory, and multivariate approaches.
No, I'm kidding. That's very exciting. And that clearly put you on the path for what you did and have done with this fine tome tonight. You were the co-founder of the fermentation lab at an obscure little restaurant in Europe called Noma, which nobody's heard of.
I went to college in Cambridge.
Yes, kind of. And then you've also lectured literally everywhere, at least all the cool places, from Harvard to South by Southwest. And you're now the co-founder of something called Retronasal Industries, right?
Yeah.
I want to know about that because you and I both have companies that are called something industries.
Oh, okay.
Mine's Brain Food, and yours is Retronasal, which is a great name. What does Retronasal Industries do, Arielle?
Broadly speaking, we help people with flavor problems.
Okay.
So it's sort of, applying everything.
So what would be the normal client for a company that services people with flavor problems?
It could be like a big food company, it could be a startup, it could be somebody looking to make a drink brand with bottles or canned cocktails and can't figure out how to do it, and are having a problem or want it to be more something, and then come and do the something.
But of course, calling it Retronasal, and everybody that's already read the book is very familiar with retronasal olfaction, which of course that's the aroma that comes up the back of the throat.
Yeah, that's the kind of smelling. When I say flavor is taste and smell, that's the smell.
It's the root that milk used to taste when we nose sprayed in the lunchroom in high school. Yes. Okay. So I'm going to ask a series of questions, and we're going to get to your questions here shortly. But this is all stuff that I really want to know. I want to know. So first off, this is one of those books that as soon as I saw it, I'm like, why hasn't somebody already done this? Which I think is a sign of a great work. When you look at it and you're like, this should have already been done a long time ago. Why do you think nobody's written this book? And that doesn't mean that you're not a special snowflake, which totally you are. But the truth is that we're all of us that are cooks are constantly in the pursuit of flavor. But no one has just out now written a book about it. Have they?
There have been books about flavor, but more about.
But not good ones.
So I tried to approach flavor systematically in this, if it's not clear by reading it. And I think some of the analytical chemistry techniques that have been developed for actually understanding what molecules make what flavors and therefore what chemistry is happening. Gas chromatography, mass spectrometry. Didn't get really good until the late 90s. So not all of the data has even been out there. And I also think it takes someone who can understand the chemistry science part and the sort of psychological perceptual aspects, and then hopefully how to use it for something, and
and then the actual culinary part.
Exactly.
So it takes three things. You have to understand the science.
Yeah.
You have to understand the emotional piece of it all, and then you got to understand the culinary piece of it.
Yeah, and so I've been told it's a problem that I try to take three things and fit them into one thing, 3 dissertations into one dissertation, and this is sort of
Well, this doesn't read.
Successful version
This does not read like a dissertation. That does not read like a dissertation.
Well, that's why it took 5 years.
Yeah, you did. You totally did take 5 years. No, this is a book that takes all of that chemistry and actually puts it in a useful form in front of people. Well, one of the things that I want to know is, was there a particular meal or experience, or even just a bite, that put you on this particular path? It's a good question.
Yeah.
We all want to know.
You know, I think it might be actually when I was little, my parents had the Silver Palette cookbook, because it was that.
Everybody had the Silver Palette cookbook. I have a first edition. Yeah, sure.
Yeah, and there was a recipe for cilantro pesto. And
indeed.
Yeah, so at one point they made a bunch of cilantro pesto that had too much, and they froze it into ice cubes, and then we would stick the ice cubes in chicken soup because I would complain that it was like too hot. And so along with cooling it and making it to an edible temperature, it was this like amazing sort of like perfumed herbal fresh thing that like bloomed out of the soup, and I was like, that's really interesting.
So does that mean that you have an emotional connection to cilantro because of fond memories, besides just liking the molecules,
Yes.
which is what this book's about, the molecules that make up the flavory delivery package of what cilantro is, which some people think tastes somewhere between soap and ass.
Yeah, I have heard that. So I understand that people feel that way. I cannot relate to it personally, because I've only ever had positive connotations to cilantro.
Understood. But do your emotions change the way, because you have that emotion from your childhood,
Yeah.
and you talk about emotion in the book a lot, but it's one of the things that you can't really quantify. You can't put it on a chart. There are no meters for reading it. So how do you think that emotional impact of that experience changes the way you taste cilantro?
Well, I mean, I know, factually and mechanistically that, when I smelled cilantro for the first time and had this like positive experience, the sort of odor image of the cilantro and the positive experience were like sort of basically stored, linked together, so that the next time that I smelled the smell, it triggered the happy emotions and memory, and your like amygdala and stuff like that. Because smell is very closely tied to emotion and memory. So I would say like you can't not have flavors in some way be affected by your emotional experiences.
Okay, then can you have a perfectly good flavor ruined in your mind by a bad experience?
Good question. I think that usually, definitely a bad experience like getting sick will do that. I don't know, I kind of want to set up an experiment now where we like give someone a particular smell before giving them like devastating news or showing them, I don't know, some, thing that they don't like, breaking up with them, and then test them later and see.
Don't those brownies smell good? Aren't they?
Exactly.
It's malignant. I'll never trust again. I do want to interrupt you because you
I mean, I wouldn't do it because it's unethical, but that's the...
Since when has that stopped medicine?
The experiment.
Or science, or anything else for that matter. When you talk about, and you mentioned this in the book in a few places, and I don't feel like I've got a really clear, I want the Arielle version straight from your mouth. What are you talking about when you say flavor image?
That's a good question. I suppose I should have said odor image because that's the sort of domain of smell specifically. Okay, so taste and smell are both chemical senses, so they are senses that have receptors that stick out like catcher's mitts and from the surface of your tongue.
Five
nose.
in here,
yeah,
and a gajillion up here.
Exactly. And grab onto molecules and generate a signal. So with smell, we have about 400 different types of olfactory receptors, and each of them sort of goes to a spot on the olfactory bulb, which is like a little bulb-shaped structure in your brain. And the way that a smell signal is transmitted from your smell receptors to the rest of the brain is basically lighting up a pattern on this olfactory bulb, and then sending that pattern off to be, recognized and processed and emoted to.
And yet most of us just say, wow, that smells like my grandmother, or wow, that reminds me of 4th grade because I had to walk across this field that was full of, we don't, I don't think that most of us form like like we hold up this thing, it's like, oh yeah, that's the pattern for childhood cilantro. We don't, no, we associate, we free associate. It's more like song lyrics than it is science.
Well, I mean, and you process the smell signal emotionally, like before you assign words or conscious thought to it. So.
And that's because of something that you talk about in the book, which is the fact that those smells are actually being detected not by an interlocutor mechanism, but by the brain itself, right?
Yeah.
I never knew until I read this book that you've literally got your brain hanging. It's like when I sneeze and my wife says, "You're gonna blow your brains out," I actually could blow my brains out. Right out, because that olfactory bulb is actually the brain.
Yeah, the olfactory bulb is the brain, and then brain cells, like long and skinny ones, come through the cribriform plate at the base of your skull, top of your nasal cavity, and just kind of like dangle in they call it the olfactory mucosa. I know there's a couple doctors here, so sorry if I'm getting this a little bit wrong, but yeah, in your nose. Actually, you can, if you get like head trauma, you can like kind of slice those connections. They grow back in like some.
But sometimes they don't.
That's true. That's true. Interestingly, the Black Widow Marvel movie had literally that as a plot point, which was completely technically accurate, which I was impressed by because I'm pretty sure accurate.
I'll have to go give that another watch.
Yeah. Watch out for that.
Yeah. When did you decide to pursue flavor scientifically, and why? Do you remember?
So yeah, I went to school here for my undergrad, went to NYU, did a bachelor's degree in chemistry. Decided around that time that I needed to be doing science and food in some form. Ended up going to grad school, UC Davis. It was also like the right decision to make in 2008, 2009, because it's not like there was anything else no one else was hiring. But I would have gone anyway. Study things I'm interested in for 5 years and get paid probably a living wage. Like, pretty cool.
That sounds good.
Yeah. But so I knew cuisine, chemistry. I had only like a little bit of an idea that like flavor was even something that you could study at all. So, case in point, like it just was not a concept that had really crossed over into the mainstream. But yeah, once I was doing my rotations in grad school, I got to use the gas chromatograph mass spectrometer and be in a descriptive sensory analysis panel, and it was just like amazing.
Yeah, I've got one of those. What is your most recent flavor discovery? Or are you now at the point where you've done the discovery?
No, there's like, I'll be very sad the day that I stopped being surprised by flavor. So I'm not so.
So do you remember a recent one where you were like, wow, or I didn't think that would happen, or that's strange?
Actually down the street south of here a little bit, Libre Bakery. I had a black lime morning bun, Limu Omani. So black limes are limes that have been usually brine marinated and boiled and then dried in the sun, so they turn like black and have this nice like leathery lime smell. So it's not like a fresh lime smell anymore. It was a pastry that usually has like cinnamon or some kind of sweet spice in it, with this like really different but very, very nice dried lime flavor.
But you're already a fan of black lime, and that actually,
I am. That's true.
I wanted to ask.
I didn't know there were
something,
sweet applications for it, though.
I guess. Yeah. Well, why wouldn't there be? I mean, when you think about it.
Well, I didn't know of any classics.
You spend a fair amount of time in your book using recipes, and if those of you that haven't read them yet, there's some pretty amazing ones. I have not cooked them yet, but I've got a list of the ones that I'm going to. But you use your recipes much kind of like illustrations of the points that you're trying to make. And I'm curious because you talk a lot about ingredients that, quite frankly, a lot of people probably haven't encountered. Black lime being one of them, kala namak, I think, am I saying that right, kala namak? Or korarima, which I didn't know, seeds, and kurosato. I want to know, did you discover all of these, we'll call them exotic, ingredients because you were actually adventuring through international cuisines, or were you specifically on the hunt for molecules? You know,
definitely more the former than the latter. I mean, I think like the things I included in the book and the like ideas I wanted to cover mostly came out of like just being really, really into the topic and finding stuff that was interesting, and then eventually being like, oh, I guess I can write about this, rather than setting out to like catalog things for a book. But I'm a big fan of like just doing research with no like particular goal, and usually it comes in very handy later for something you've never interested.
So you like to wander.
I do.
You're an intellectual wanderer. Meaning that you rather find things that you stumble over than like, I've got to go get this.
Oh yeah, I'm sorry, I'm laughing because I think that was something that was said negative of me
No.
in grad school.
No, was it? Yeah. Well, this ain't grad school.
Not focused enough, but.
No, this is by no means grad school. You spend a fair amount of time in the book, and those of you that have read even a little bit will probably pick up on this. And in the discussion of we're encouraging people to change things out, changing out the expected for the unexpected. Exchanging ingredients with one another, because you talk a lot about classifying, thinking of new ways of classifying groups of ingredients. I'm curious, have you found, and she does this brilliantly throughout the entire book, and I think it's the kind of thing that can change my cooking, certainly. Have you found that there's maybe one ingredient that you've encountered that simply, besides salt, that simply cannot be exchanged for anything else? Because we all know that salt is salt. It's the rock we eat, and it's the one thing that probably can't be replaced. But have you encountered anything else? Because you spend a lot of time in the book replacing things and changing out bits and pieces and parts in a rather Frankensteinian manner.
I mean, it's a little unfair because salt is both an entire flavor and one molecule. So like the ingredient is the molecule that
one molecule, but two atoms ionically bonded. So
right, but yeah, yeah, that's true. So yeah, in a general case, I don't think so. I mean, one really specific one would be like there's just things that really only work with white sugar and not with like sugar that has a flavor, because it's supposed to be either. So
just sweet.
Yeah.
Just sucrose.
Exactly, just sucrose. So jams and very like delicately flavored cakes and stuff like that. There's just, I think the Western pastry canon was developed to show off white sugar, and you can.
And you just can't trade it out.
Yeah. I mean, you can, but you're not going to ever get like the same.
I didn't see that one coming. I like that. I'm going to skip that. What are the steps to learning how to productively taste food? Where does the beginner start at, say, my age? No, because I'm at the point, quite frankly, where I can smell and taste a lot of things and recognize them, but I no longer have the, I'm losing my ability to describe them, other than, it's basil, So how do people, anybody here who wants to be I'm not going to say mindful, I'm going to say more attentive eater, are there any, what's the first step? And you do talk about this, but I want you to boil it down a little bit, because I think that you go through the steps in the book, but I want like just a rule. What's the starting point?
Pay attention.
Okay.
No, but like while I think we're often out of the habit of paying a lot of attention.
But I mean, do you now? For instance, I believe that our cultures, we are losing our ability to concentrate on anything, by and large, in general, kind of culturally speaking, and that makes it very, very difficult for us to enjoy our food, because we don't stop, we don't think about it, we don't savor anymore, but savor is also an intellectual operation, isn't it? So, when you're telling somebody to do this, somebody who's just shoved Snicker bars in their tray, which are delicious.
Yeah, well, they're designed to be.
Yes, they're designed to be, and also to have absolutely no actual value in any way, fashion, or form. Please don't sue me, people of Mars. But I do want to know what's the point that you can look at somebody and say, all right, I'm going to give you one tool besides pay attention.
No, but like.
Because when I grew up, pay attention was always married to being hit in the head.
Oh no!
Pay attention.
I mean, sit with the sensory experience that you are having while you are having it.
Is it better to do that by comparing to something else?
So so you asked for one rule, and so I would say, like, if we're adding rules on,
permission to treat as a hostile.
Then one of the pieces of advice would be and is, like, if you're interested in learning more about a flavor like citrusy, just smell and taste a lot of versions of it, and you know, smell and taste them side by side, and then like.
I thought you said something different.
Yeah. First, like, you know, just 5 different grapefruits, a pomelo, I know why you're laughing, an Oro Blanco, like, you know, 5 different kinds. So you might have like some vague idea of grapefruit, like before you do that, but if you sit down and then like smell them in succession and compare them to each other, like first you'll notice that they are different, and then the more times you do it, the more ability you will have to maybe describe what is different about them.
Okay,
so the fact that you say that you can still like distinguish flavors, like that's great. You're like all set to.
But I can't describe them. I'm really bad.
That's just practice.
Is it?
Yeah.
Is it really just practice?
It is practice.
I mean, no joke.
Yeah.
So just having to look for, okay, this smells like woodsy and grassy.
Yeah, I mean, and then like smell pieces of wood and smell grass.
Do you ever actually do that?
Oh, all the time.
Do you have like a rack of smells? No, I'm serious, because like when you're trying to figure out, okay, I am smelling this, let's say that you stumble across some really kind of, you know, unusual herb from Nepal.
Yes.
And you're trying to figure it out, right? Do you sit and say it doesn't have any members of its family? Okay. There isn't anything else.
Great.
So you sit down and say, okay, I'm going to smell this piece of wood, I'm going to smell this piece of this, I'm going to smell this, and then I'm going to go back and smell that thing again?
Well, I don't usually have the opportunity to do that, but.
But then what do you do if you're really getting a new flavor or aroma into your head from an ingredient you've never seen before?
Yeah.
How does Arielle Johnson approach that?
I mean, I usually like sit and keep tasting it and kind of like free associate badly until I like hit on the thing that I know that it's like.
Do you have to cook with it in order to get that clarity?
I mean, maybe.
I mean, like actually do something to it, change it somehow?
I mean, no, I think just like tasting. I like to taste raw ingredients too, so that's another thing. Another thing you can incorporate into your everyday life is like following a recipe, but then just like taste what it tastes like before it goes in.
Do you think that people do that enough?
No, I think they should definitely do it more.
So if I was going to make a vegetable soup with 13 ingredients and I've done all the slicing and dicing, I should stop and taste everything individually.
Yeah. I mean, like, if that would make cooking not fun for you anymore, then like you don't have to do that, but like definitely. I mean, you know, just building up a sort of mental bank of like, all right, what does carrot mean and how different can carrot be?
Right.
And still be a carrot.
Well, I think that eating starts with cooking. To me, the sensory experience of eating, which is multifaceted, actually starts when I'm handling the ingredients to begin with. It's the tactile experience of chopping things up, the aromas of cooking, the feel of things, is to me all the same thing.
Yeah.
But that's.
I think if you cook and then eat, then it makes total sense.
Well, it's hard to eat and then cook.
Unless someone else cooks for you. But yeah.
Talk about how and why you developed your laws of flavor. A lot of this book is really held together by the structure of your laws of flavor. And I'm really interested in how you came to that, because I sense that you were looking for something really structural that you can hang your hat on, and that you decided to go with these laws.
Yes.
And I want to know how and why that happened.
I mean, how it happened is I was like sitting on a bench in London thinking about, oh, I have all these ideas, I should think about how they go together, and then it just like came in full kind of comprehensive form once I thought about it long enough. But and I also like, so I can do that, but I also can't remember.
But laws are strict things, right? Laws are
yeah,
to be broken.
They are,
and if you do break them, there's a penalty.
So with the laws, I was trying to cover like everything that is always going to happen with flavor and molecules. So like flavor is always going to be taste and smell. Like sour isn't always going to be lemony or, you know, vinegary, or like, oh, you should cook this thing, you should cook that thing. Should is not part of it. So like flavor is always going to be taste and smell. It's always going to be molecules. There's always going to be opportunities to like move molecules around in your cooking, whether that's like making a cup of coffee or, you know, a flavored oil or something like that. And then molecules also react with each other. So there are, you know, processes that we do that create flavor at a molecular level. The Maillard reaction, browning is a big one, but also, you know, caramelization and fermentation is a powerhouse of
caramelization and Maillard reactions are related, right? I mean, they're both brought on by high heat. but one's
and you
more
get a lot of,
protein and one's more sugar.
So the Maillard, caramelization is when you pyrolyze sugar. So you just have sugar and you're breaking it down thermally. The Maillard reaction actually happens at a much lower temperature, and that's between sugars and free amino acids. And since amino acids all have nitrogen in them, and some of them have sulfur and other like sexy elements that aren't in sugars, you get these weird aroma molecules out of it that smell very like particular to that reaction. So like the smell of roasted coffee, for example, is like from a sulfur-derived Maillard reaction product.
That you couldn't get out of the coffee if you didn't roast the coffee.
Oh, you couldn't get from sugar alone. You couldn't get it if you didn't roast it, and you couldn't get if you only had sugar. So like protein is the sort of.
So when you say laws, you're really saying these are touchdowns you can depend on. These are things that aren't going to change and will always be true and won't let you down.
Yeah. So I can't tell you like a recipe that will work for like every single coffee bean that you encounter for making a cup of coffee, but like I can explain to you at a molecular level, you are selectively moving molecules around, and that will always be true of making a cup of coffee.
Does the science ever let you down? Meaning, have you ever stumbled upon a flavor combination that on paper and with gas chromatography and all these things was like, yes, this is going to be fantastic. And you tasted it and you were like, I need a bit.
Well, see, like I don't think science is actually very good at identifying what's going to be good in advance. There are like some kind of theories around it, but the like empirical evidence for combining flavors together based on what molecules they are is like not very proven. So like I don't know. See, like that makes it a fuzzier question of like, oh, so is that like not a scientific question anymore? Like kind of isn't, but that's the aesthetics, the feeling, the personal preferences, that is what makes it interesting.
I guess I thought that. All right, I'm gonna go back and think about that one for a minute, because one of the things that I took away from the book that made me feel good was that I understand why this goes with this, or I understand why in this it's like years ago I started putting grains of paradise in my apple pie.
Okay.
I could not explain to you why. I didn't know why it worked, and I couldn't even get my head around what grains of paradise even smelled like. It was like it was a slippery concept. It's like I'm getting this, I'm getting earthy, and I'm getting where I don't know what it is, but for some reason I think it's going to go with apples, and it did. It worked really well with apples. I don't know.
Okay. So I was taking your question way too literally.
No, I'm just shifting because I don't know the answer. So.
Well, I mean, it's interesting. So like I guess the concept like, well, why does like grains of paradise works in apple pie? I guess like works is like it's similar enough or hits enough of the like right buttons to like stay within your mental concept of what apple pie is, because it's like you want a a kind of like fragrant spice in there. So like cinnamon works, and there's some overlap with other spices.
Yeah, but cinnamon's always like, I'm cinnamon.
That's true.
And I'm here. Whereas grains of paradise is sneaky. It says I'm something, but you don't know what I am.
It's kind of between like cardamom and black pepper, but not exactly.
And I think I came to it because I was putting black pepper in my pie, but then it was like, oh, that's black pepper, and it didn't work for me.
Yeah, well, you probably had too many associations to savory foods.
Maybe.
Yeah.
I mean, associations definitely get in the way, don't they? Or do associations get in the way more than they help? Do you think? For most people?
They can, and especially in terms of tasting new things. If you have a lot of associations outside of food for a flavor or a smell, and then experience it in a food context, it can be like kind of upsetting.
Yeah, like say shampoo.
Yeah, or a lot of Europeans that come to America, they don't like root beer because they don't have anything food that tastes like root beer in Europe, but they do have toilet cleaner that smells like root beer. So why would you drink this?
Is that true?
Yeah.
Well, like, I use the opposite to get to things that I like. Like, by the time I was 6 years old, I really liked Scotch whiskey.
Okay.
And the reason was because it smelled like Band-Aids.
Yeah.
And I loved the way the Band-Aids smelled.
Yeah.
So I was attracted to Scotch through the Band-Aids.
I used to love the smell of gasoline because it reminded me of the smell of like really freshly ground coffee when it's like super pungent. So when we, it was maybe like 3 or 4 years old. When we go grocery shopping, we
Were you
get
drinking coffee? When
No,
you
but
were
I'd open up the
first?
bag and like huff it on the way home.
You're a coffee huffer.
Yeah, I was.
I like that.
I love the smell, did not like the taste.
I was drinking scotch
Yeah.
out of a
Yeah.
Band-Aid box, and you were huffing coffee. That's good. Do you remember anything else from childhood like that? Because I'm sorry, I can't. When I think of gasoline and I think of coffee,
Yeah.
Anybody get it? Do you do? You get that? You get the association?
Yeah, it's right there.
It's right there. Not so much with brewed coffee, but specifically like relatively freshly roasted coffee beans.
Okay.
They have this like very pungent top note to them. That I mean, I don't think it's the same as what's in gasoline, but like the kind of I don't know, prickliness of it was echoed in gasoline.
Interesting.
Yeah.
Do you remember anything else from childhood? It was like, huffing coffee grounds.
Yeah.
'Cause-
No, that's really the big one. I mean, I used to my ice cream order was always orange sherbet with Reese's peanut butter cups, but I don't know how to do it.
I need a minute. Now we finally got something we can talk about. I want you to talk to me about orange sherbet and peanut butter cups, because that's unusual.
Yeah.
Does anybody here ever had orange sherbet with? I mean, I'm gonna have it tonight, I promise you, when I go home. But I want to talk about because now I'm starting to understand your career path. No, really, because I mean, here was a kid. I mean, how old were you when you started putting Reese's peanut? Did you eat them side by side,
two or three.
or did you put it inside?
Oh yeah, mixed like kind of like crumbled up
And-
peanut butter cups, like stirred with it.
I want you to go back in your head and try to remember the first time that you thought this was a good idea and the conditions by which this would have been rendered possible.
Right,
Because your
right.
parents did not put Reese's peanut butter cup down next to the orange ice cream. We came
I don't know that.
No, we came from the generation where the only thing you shoved Reese's in was a jar of peanut butter, am I right? Because that's what the commercial said.
Yeah.
So tell me how that happened, if you can.
I mean, they had orange sherbet at the ice cream place we'd go to. They'd have Reese's peanut butter cups as a topping for ice cream, and I think my little like sensation-seeking brain had them separately, and then was like, well, what if I had all these very different things that are intense like together? That might be great, and it was.
Well, I like intensity, but I'm not going to drink orange juice after I brush my teeth with peppermint toothpaste. Do you still like it? When's the last time you had?
It's been years, so maybe we need to run this experiment.
We're going to have to run this experiment
yeah.
again. That is actually incredibly interesting. One of the things that you talk a lot about, and you get further down in the book, you guys can have your questions here in a second, is you talk about making new molecules, forming new molecules, bringing new molecules to the party. And of course, one of the ways that you do that and have a reputation for doing that is, of course, through fermentation. If you ask me, Americans are still a little bit squeamish about fermentation. Can you talk about maybe a good beginning point for the first ferment?
Yeah, I would say creme fraiche is a good one. It's very simple to make, and it's like pretty much instant gratification, and if it doesn't get sour, don't eat it. So it's obvious if it's been successful or not. So I think a lot of people are like apprehensive about it failing and not knowing it's going to fail. Their first fermentation, whatever that is. And they don't want to like wait and see, because some stuff takes like 6 months. So
Right.
creme fraiche you can ferment like in 18 hours. And it's as simple as taking old creme fraiche or buttermilk, adding it to heavy cream, and then just letting it sit.
Letting it sit.
Yeah, it makes itself.
I remember the first time that I made yogurt from scratch, and I thought I was a wizard.
Yeah.
I mean, because it was such a magic trick that I had just taken all this milk and converted it in a matter of hours to something that ordinarily I'd have to pay for. Is fermenting kind of a regular and natural part of your culinary life? At home?
At work, yes. At home, less, just because, I mean, anyone who's lived in a small New York apartment has to be knows that you have to be selective about like what smells you have. And I don't live alone, so I have other people to, I mean, it's not like bad, but like some people just don't want to walk around smelling pickles all the time. Like, I don't know why, but it's valid.
I'm for the pickles, so I don't know about you guys. All right, I don't have much time left, so I'm gonna go from a flavor standpoint. This is actually something I wanted to ask you What is the most powerful cooking method when it comes to the creation of flavor?
I would say cooking over a wood fire.
And that's because the incredible array of molecules that are brought to the party?
Yeah, well, and you're basically at least 3 completely different pathways to generate flavor are happening at the same time. So you're burning the wood, so you're generating smoke, and flavors from flavors from smoke don't show up in a lot of other stuff. I mean, the sweet vanilla whatever shows up, but can't get smoky flavor any other way. So you're making smoke that gets on your food. That's great. The temperature is really high, so you're getting browning and charring directly of whatever you're cooking. So that's another second flavor pathway. And especially if you're cooking any kind of animal product, as fats melt and drip onto the coals, they generate a very, very particular grilled aroma that you can't get without fat dropping on red hot stuff. So,
is there something to be said for the fact that that is a seminal event in human history? The fact that we learned how to unlock nutrients using fire on animal flesh, and everybody in this room, even if they're a vegetarian, we're all watering at the mouth just thinking about the animal fat dropping. I mean, most of us are. Some of us are better, but I'm not. But that's not just molecules working for good flavor. That's ancient genetic stuff going on, isn't it?
Yeah, I mean, I think Richard Wrangham is one of the people who works on that the most. The idea that cooking was not only something that we figured out how to do as early humans, but literally by making food easier to digest and get calories out of and easier to chew, even allowed us to grow our brains to become human. So cooking made us human. So I think, I mean, the tricky thing is you're if you're trying to prove this, you have a combination of looking at the anatomy and tooth size in different skulls of different hominids, and then trying to find evidence of fires in archaeological sites, but there's no sign pointing to oh, well, this was 3 million years ago and they were definitely making fires to cook over. So there's a lot of circumstantial evidence around it, but as far as I know, it's a pretty well-respected theory. So,
Agreed.
Yeah.
Agreed.
Fermentation too was probably
because whoever learned how to ferment lived through winter.
Yeah, so that's actually why we can taste sour.
Because we developed it, right?
So if you're eating food with no refrigeration, some of it's going to be microbially transformed, and some ways are ways that you like, some ways are ways that you don't like. Generally,
rotten.
Yeah, exactly. Rotted versus fermented, it's a kind of line of perception. But generally, if there's fermenting bacteria that make acids, it's safer in terms of spoilage and poisoning and stuff like that, and it lasts longer.
Because when the pH goes down,
exactly, because the acid
microbes go down.
Exactly. So you have to, these bacteria have actually had to develop a special skill of surviving in acidic environments, because most can't. So if you can taste the difference that that's sour and the other thing isn't sour, and you have the ability to like sourness and then keep eating the sour food, then you've developed the physical stimulus, the sourness, the process that sourness comes from, the fermentation, and the sensory, the pairing of those two things, that then will let your descendants thrive much more than ones that cannot taste sour and therefore won't eat fermented foods deliberately.
Because everything, and you talk about how simple our mouths are, palates, which are five things. That's all we can taste that we know of right now. That's accepted.
Right.
It's 5 things, and they all have very specific purposes.
Yes.
Right. Sweetness is calories.
Yes.
Umami is glutamates or glutamic acid, so protein, building blocks, amino acids. Bitterness is a warning for poison, or also Campari, depending on. It's not poison. Sour is not just a marker for fermentation, but also for vitamins.
That's true. Yeah.
Right. And then salt, we've got to have for pretty much every single function.
Yeah.
All right. Last question, and then we'll turn it over to everybody else. Okay. I really want you. I love the book. I'm absolutely, devastatingly jealous of the illustrations.
Oh.
you have managed to take high, scientific stuff and make it, I'm not going to say childlike, but you have, because they're not, but to make them incredibly friendly conceptually. So I was hoping that you would take a moment to talk about your illustration process. And did you find kind of new ways to communicate? Because I know it took a lot of time for you, and you're not like a trained illustrator. Did the process of learning how to do these illustrations change the way that you communicated what you did through the book? Did it bring new words, or did you find that there were things that were just better to do with pictures? Because it really is a beautifully illustrated book, and not just attractive, but very, very educational in a way that even somebody like me can understand. How did it happen? How did that all?
Well, the whole point is like communication. Is like I know things, and like someone who is hearing me talk or reading does not know those things, and we want to like transmit those as effectively as possible. So like in the sciences you have like diagrams all the time. That's like, it'd be weird to have a science paper without any like illustrations or charts or diagrams. Or
you got to break up all those big words.
Exactly. The long text, the footnotes. So like I did, and I personally did a lot of like data visualization for my PhD. So I was like used to having like a visual representation available to show more than I could like say really. And once I was no longer in grad school and started giving more talks to non-scientific audiences, chefs and the like, it was like even more important to like convey information as fast as possible. So like diagrams and flowcharts and drawings of things was like the most effective way.
Is it harder to explain scientific things to chefs or culinary things to scientists?
Yeah, I think pretty much anyone can like learn the science. If someone like doesn't have like an appreciation both for like the sensory, sensual experience of food and why that is important, and why there is like maybe a cultural value to that, it's like very hard to convince them otherwise.
Interesting, and that's because their world is kind of blocked up and very logical and doesn't have room for human stuff.
I mean, I don't know, I don't think that way, so like.
You don't, clearly. So.
Well, no, but like I don't know, I mean, I don't think people should think that way, but a lot of people.
I want you to write a children's book. No, I think the kids need to learn how to eat, because we're doing a crappy job teaching them by and large.
Right.
I think it would be a wonderful thing for you.
Well, I think like understanding what you are tasting and being able to talk about it is like a huge part of developing a palate, learning how to feed yourself, but also like maintaining your autonomy, where increasingly
I'm not going to eat the peas, and here's why. These are the molecules that I don't appreciate.
The pyrazines are too intense in these mother.
I've been saying this for years. The pyrazines are far too intense. Let's. I know that we're running out of time, so let's take questions from the audience, and I'll just sit and point. Anybody? Question? How about over here?
Hi, thank you for this. My brain's exploding in about a million different ways.
And not just the part that's hanging out of your nose.
Exactly. When you're trying something new, are you someone that can remain fairly neutral in your associations, or do you kind of just like know where your emotions, memories, allegiances lie to certain molecules and flavors, and just kind of like are present to that while you're tasting new things?
I think for me, like both happen at the same time. Like I don't know if you can ever completely divorce yourself from the like emotional reaction that you have to a flavor or to food. But I do have a lot of practice of sort of setting that aside and trying to like think about what I am smelling and tasting as like objectively as possible, like descriptively. So.
Is there anything you just hate?
That I hate?
Yeah, food. We all want to know.
I have to. I mean, it's not like a particular ingredient or anything. It's just like
I hate beef liver.
Like chicken cartilage outside of a context where it's supposed to be cartilagey. Like I don't like. But
well, who the hell does? I mean,
there's amazing preparations of like animal cartilage. And
sure.
Deliberately. Yeah,
but when it's not done deliberately,
it's
that's
not
a
supposed
problem.
to be there. I don't like it.
Anybody else with a question? Over here. We'll get a microphone over to you.
Thank you again, great talk.
Thank you.
Thinking about your work with retronasal industries,
Uh-huh.
one of the hardest parts about being a consultant is the clients.
Yes.
Can you help me understand, when you're working with flavor professionals, large organizations, small experts, what's the thing that they don't get that you're able to help them understand?
It
Great
actually,
question.
it depends. In some cases, like they're very technically skilled in chemistry, experimental design, stuff like that, but they don't have any idea about how like sensory science works. I mean, I've worked with companies where they've hired chemists that are excellent chemists that mostly work in pharmaceuticals. And there's just like things about analyzing smell that you don't learn in any other branch of analytical chemistry. So there's just like a lot of counterintuitive stuff you have to do that like they don't know about. So I tell them what they need to do in that case.
Can you give an example?
Well, okay, so we are sensitive to different smell molecules to like vastly different degrees. Some things we might only be able to smell if there's like a few parts per million of it. That's actually a high concentration for a smell molecule. So we're talking about tiny concentrations to begin with, but like 10 parts per million is like a lot. Then there are other things that you can detect down to the like parts per billion or below. So like 5 orders of magnitude fewer molecules. That's things like, the pyrazines, the sort of green pepper molecules in green pepper, a lot of sulfur molecules, so like that kind of passion fruit note in, passion fruit, but also white wine. Cork taint is one of them too. Geosmin, which is the smell of dirt and beets. So if you know that there's molecules that you're interested in, because those all come from molecules, you can run them through a gas chromatograph mass spectrometer and get like a readout of like how many of this molecule there is. But until you start to take into account how sensitive humans are to each of those things, like the chemical data cannot predict how anything is going to taste. So like the most important molecule in the entire mix is often not going to be the one that you get like the really big peak from. So like the trace, there's a peak for that. So it might be like this tiny one there is like the key to everything.
But
so like black pepper is one example.
And those are edibles, but but the truth is if I'm out in the middle of the woods, the molecule I want to smell is bear. I want to detect it long before it detects me. Right? So that's got nothing to do with food, but it does have to do with survival.
Yeah. Well, I mean, like, we talk about, or I even talk about that, like, certain tastes are designed to do this thing. I mean, nothing is designed to do anything. Everything in evolution and biology happens like completely randomly and by recruiting things that we already have sitting around, not by like building a completely new thing. So if you have this like, I mean, I don't actually know which came first, whether it was a food thing or a survival thing, but if you have this system to detect tiny amounts of molecules that come to you from far away, you may as well use that for both like sensing bears and telling if something's cooked.
Lovely. Does somebody else have a question? You did, ma'am. Go ahead.
I would like to know your take on pineapples on pizza.
I'm not opposed to pineapples on pizza. I don't think they work in every circumstance. They do work well with bacon. Also, I had an al pastor pizza from my like Mexican pizza place near where we live in Queens that had little bits of pineapple that was excellent. So definitely there's a place for pineapple on pizza.
Wow, dangerous concepts being coming up. Do you like pineapple on pizza? Yeah, for me, it's not the concept of it being on pizza. It's the pineapple with cheese that gives me problems. So it's like with the cured meats, the bread.
Too much would be too much. Yeah. But I mean, do you ever like a little bit of membrillo paste with your cheese?
No, because I've never done that.
Really?
I mean, I have it, but I've never thought to put it in.
Manchego cheese and like a little bit of like
sure,
paste.
sure.
Yeah.
So quit space.
So I mean, this is a great case study where like pineapple and cheese feels too weird for you, but like
melted mozzarella with.
No, I'm not saying it's not valid, but I'm saying if you want to come to appreciate like pineapple and on pizza and are put off by the cheese, like you could start with other kind of fruit and cheese combinations like that you already like. So the concept of cheese and fruit is not the issue.
Well, clearly cheese and fruit go together
Yeah.
because there's always fruit on cheese platters. It's
True,
just
true.
in that milieu.
Right. So I mean, I'm not saying you should like it, but there may
I
be
feel left out.
there may be a way to come to like it. If you want to, you don't have
Maybe
to.
there's a bridge fruit that would,
Yeah,
that would
exactly.
give me,
Thank you.
like
That's a much more succinct way to
maybe
put
I
it.
need guava before I go to pineapple.
Right,
Maybe I need something
Quince
else.
or-
Quince.
yeah.
Well, I'll use the quince paste
Yeah.
because that makes
That could be really
sense.
good.
And then I can put figs on my pizza.
There you go.
Which that is
It's delicious,
good.
yeah.
That's delicious. How about you?
Well, I'll start with a comment. I think I would like to postulate first of all that it's hot cheese and fruit. That's
Yes,
the
the
uncanny part.
melted mozzarella hot cheese.
Yes.
Thank you. Yes, I have a problem with that.
Right.
Your postulation is correct.
Grapes next to the fondue pot are a refutation of that postulation, unfortunately.
Yeah, I think that sucks too.
My hypothesis disproven.
Sorry.
But to go back to sort of what y'all were saying about context and the smell you notice as a bear, there's a lot noticed about the chemistry of food itself. But are there any cool chemical associations with the environment where food is served that you can think of? Think of how, like, if you're on a picnic for some reason that makes a baguette taste really good. I don't know why. Are there any cool interactions with like specific environments that?
Yeah, I mean, like, context is like a huge part of enjoyment. So, when we use flavor to tell us what to eat, but we really use like all of our senses to figure out like what's good to feed ourselves and what's not bad. So, if you want to learn more, there's a psychologist named Charles Spence who specializes in exactly that, studying how environmental cues change the perception of different sensory things. Cross-modal is what they call it, so it's crossing, vision or sound and into like flavor, different modes.
Did that answer your question?
Yeah. I just wasn't sure if there were ones that were like smell or specific. That stand out.
I don't know if they're like universal things. Not that I can think of, but like,
Those would all be
it is a
experiential,
very
wouldn't
general, thing that definitely happens, but I don't know if there's one that's universal.
Like I associate the smell. You ever have a situation where an environmental aroma enhances your enjoyment of something? Like for instance, for me, it's the combination of pool chlorine and roasted marshmallow.
Yeah.
And that's because the first time I had a s'more was at a swimming pool.
Nice.
And I've gotten to where I've associated that.
Yeah.
But that's more Pavlovian, isn't it?
Probably. Well, I mean, it's all Pavlovian, or it's about
Oh,
experience.
there it
It's
is.
all about
Pavlovian.
associations. It's like food tastes. I think food tastes better like sitting next to a fire and smelling the smoke. I think that's great. So I'm
Do you
agreeing
think
with
all
you.
foods taste better if you're sitting next to a fire? Do you prefer your orange sherbet and Reese's peanut butter cup next to a smoldering fire?
It sounds great. So
It does sound good, but that's...
it needs to be tested. But.
Any other questions? Hey, how about somebody over here? How about the guy in the purple?
So, someone that I work with has been saying that they think that they can smell when a dish is fully seasoned, and everyone else that we work with very firmly refutes that. And I'm wondering if there's any basis for this whatsoever.
So we're using the professional chef definition of seasoning as salt.
Seasoning is salt.
Okay,
correct.
so well seasoned means well salted. So salt itself cannot be smelled. It's non-volatile, so it never like reaches your olfactory receptors. Sorry, I'm like hesitating to say definitely no, because like I kind of feel definitely no, but like in theory, adding salt to something will make volatiles more volatile. So like adding salt to stuff will make smell things more smellable. But usually that happens at like 10% salt concentration, not the like 0.1% or whatever that I think is well seasoned. So I think they might be either lying or like thinking that they smell something and I don't
Make
know,
them
just
prove
making
it.
a lucky guess.
Make them prove it. Make three pots of pasta, but only season one of them properly and tell them to smell them and tell you which one it is. And then you can...
We haven't gone so far as to test that.
Well, I think it's time you go that far, because that would be the only way to be sure.
Yes. Empiricism.
I could be loud. So
So how do we use our smell for umami-based flavors? Like when I smell soy sauce, I smell soy sauce, but I'm not gonna taste it when I add it to things.
Oh, why not?
Well, I will.
Sorry, I'm not trying to like tease you. Because I mean, I love tasting stuff like soy sauce. So I mean, just like a little bit.
Sure.
Yeah. Well, I mean, so yeah, so something like soy sauce you are adding for umami, but you could add like miso versus you know, Korean all soy ganjang, or like a shoyu which has roasted wheat. So like it's gonna add other flavors besides umami as well. So like knowing what it's going to do is nice.
And if you just want to add umami, just use MSG and call it a day.
Yeah, that is
Yeah,
available.
go to the source.
How or do you think science help us understand quality in food? I work in the food and wine industry. There are a lot of competitions. In fact, it's like one of our favorite ways to get together is be like, let's pit all the olive oils against each other. We assess wine. People give it point values. I would love to hear your take.
Yeah, I would say that science can measure what people's preferences are and what consensus, if any, exists about those preferences. It can't measure quality in the like aesthetic sense. I mean, there's just like nothing to measure. So you know, you can use different. You know, in sensory science, we call it like consumer sensory science because we're interested if consumers like something or not. So you can measure like preference and degree of liking, and you can even like correlate that to like how things actually taste, so like specific qualities of the food. But that's like for the population that you're studying in that moment in time. So it's not like quality by any kind of objective standard, it's just like what preference exists. So I mean, if you know what you like, you can then chemically understand what's driving that and try to like increase that, definitely. But in terms of like being able to measure quality, it's like you just can't do that.
And I'm glad.
Yeah.
I'm glad.
Yeah, no, I think it's a good
Personally.
thing, honestly. But
Do you have time for one more before we got? How about maybe we'll do a couple more.
So I was told growing up that if you taste something and you initially have an aversion to it, that you need to taste it at least 3 more times before you definitively decide you don't like it. So I'm curious whether there's any scientific basis to that, or whether it's just something that, you know, parents say to coerce their picky eaters into trying something again.
So I don't know if 3 times is a universal number, but like, yes, generally there's like a degree of unfamiliarity where, you know, something can be a bit unfamiliar, but if it's a bit familiar, we tend to like it even if it's new. If it's like too unfamiliar, we don't like it. But then the more times you expose yourself to that flavor, the like less unfamiliar it becomes. So instead of, you know, activating like, oh, new weird thing, you might be able to come to appreciate it, or, you know, disappreciate it for its actual like qualities. So yeah, I don't know, it might depend on the person. I don't know if 3 times has been experimentally determined or not, but yeah, generally, the more you return to a flavor, the more you like it. Generally.
But does it ever go the other way? Like, you like it less and less every time you try it?
Yeah, I mean, I guess it's possible. Like, it would depend on how many like negative associations you have with it, or
So it can't just be that there's something chemically going on that your body's just deciding, yeah, this isn't coming here.
Well, I mean, spoiled food, but generally. But besides that,
Okay.
yeah.
All right. So we're all automatically wired to not appreciate putrefaction in our food too much.
Yeah.
Unless in Iceland, where they bury their sharks.
Well, so
They make a hole, they put a shark in there, they pee on it, they cover it up and leave it for a year.
So I think there's, I mean, well, you could say the same thing about like camembert. You take like, you know.
No, I can't.
No.
Because
They take like beautiful, delicately flavored milk and coagulate it and make it moldy and then make it have the aroma of like mushrooms and, you know.
It sucks.
In fact,
Athletic
yeah,
sucks.
exactly. Like people generally don't like it the first time that they taste it because they have all of these like negative associations with it. So, sorry, I'm just trying. I'm being very literal about this question. I don't know that we have proved in science that there is any kind of smell that everyone is universally attracted or disgusted by, like without any experience. I would imagine there probably are, but for the most part, our responses to smells and flavors is learned rather than innate. In the smell sense, taste is pretty innate, but you can also manipulate it.
Fascinating. All right, we'll do like 2 more, and then we'll bring how about the gym of the class?
Thanks for the information, Arielle. From a person not in the industry at all, I'm really curious at a molecular kind of chemical level. What's the most, settle this for us, where do you, what coction do you eat your meat? Like, it's like, I know it's cultural, sometimes it's snobbery, but like some people are like, oh my God, like, well done, how dare you? But like, what is the right chemical level to consume your meat at a restaurant? And well, of course, put aside like quality of the meat, marbleization, all that stuff. And follow-up question is, how do you eat yours?
Like science can't decide about aesthetics?
Yeah, I think. I'm curious with all your knowledge, and also how do you eat yours at a restaurant?
I mean, yeah, I will generally like go with I'll ask what the chef suggests and go with that. So some things are actually better at like medium. I mean, like a lot of lamb is just because it can get like kind of sinewy. But yeah, then that's a combination. That's like a textural thing rather than a flavor thing per se. Yeah, I mean, mid-rare is a classic, like for a reason, but you know, and for any like, you know, well, this thing is medium rare, therefore it's good. A dish like that you find, you're going to find a like fantastic thing that can only be well done, and another fantastic thing that can only be eaten, you know, raw or almost raw. So, you know, I'm giving a very scientific answer, which is it depends.
So you're in a restaurant, you would rather just say, I'll have it the way the chef wants to make it.
Well, yeah, because they've like cooked hundreds of pieces of this meat before and know what it responds to and how it's gonna cook up. So like definitely.
If you're cooking a steak or a roast yourself at home, do you like to like leave that stuff out to dry for days and days in the refrigerator? We've talked about this. We've talked about this. We did.
Yeah.
I like my meat funky. I'm not gonna lie. I will salt a steak or a roast, and I will put it in the refrigerator for a week and just let it sit there and think about what it's
Dry aging.
Well, dry aging, but not, because
very light dry
even if you're not getting the enzymatic changes, you are driving away, you're evaporating moisture.
Right. So you're evaporating moisture. Water is really good at absorbing heat, so if you try to brown something wet, the water is going to absorb all of that heat, turning into steam, and none of it's going to brown the stuff that you want to brown. That's why it turns gray. So by removing water, you can make more of that stuff happen more deliciously. You're also like concentrating all of the meat juice, essentially. And there's a lot of, besides browning, chemical reactions that happen in the meat juice when you're cooking. So you know, the more concentrated it is, the more intense that flavor is going to be.
And a lot of people don't think about the fact you bring up the water thing, and the fact that the water doesn't brown, and that I get so frustrated when people want to base their Thanksgiving turkeys with melted butter, not thinking about the fact that butter is at least 8% water.
So clarified butter.
So clarified butter, if you
just
must.
Melted butter, yeah, it's going to add water.
All right, one more question, and then we'll sign books, or she's going to sign books. I'm not going to sign anything. Go ahead.
Okay, this was so cool. I work in the bourbon production industry, so I'm coming also towards flavor, from that perspective. And the kinds of flavors that we work with in bourbon are massive, but also there's a lot of non-food flavors like tobacco and ash and leather. And just like for my own curiosity, are there any like non-food flavors that you find particularly interesting, or like what's your favorite, or just, I don't know, can you talk about like flavor that isn't food?
Yeah, I mean, so like besides gasoline, I do like the smell of leather. I like the smell of dirt. I like the smell of.
But you don't necessarily want to eat them.
No, but I might like welcome just a little bit of that flavor in like a beet you want to taste a little bit
like dirt.
Yeah. I mean, beverages are a great place to have like lots of weird flavors. I mean, if you think about it, like. Well, bourbon is kind of a weird thing because it is an alcoholic beverage, but it's like a tincture of wood, essentially. It's like oak tincture. So like well, oak isn't a food thing, but we've made it into a food thing because it's an essential part of bourbon.
I'm curious, are you talking more about flavors or aromas?
Flavors.
Okay.
Yeah, I like a lot of like perfumery ingredients, like sandalwood. I mean, like once you put it in a food, then it's technically a food flavor. So like, so I'm cheating a little bit, but yeah, there's a lot of good ones. Do you have any?
Do I have things that I want to smell that aren't necessarily food?
Yeah.
Well, I'm not huffing gas, but I mean, one of my problems with book signings is Sharpies.
Oh yeah.
Yeah. I like Sharpie smell.
Yeah.
So, you know, I guess I would huff a Sharpie, but
I mean, I love
but it's the
smell
same
of
thing, isn't it?
But
These are very, very, very volatile molecules.
Yeah.
You know, I'm probably the oldest person in the room. Mimeograph machines in school, does anybody, okay, you agree. Yeah. The gray beards here. But that aroma, which is related to petrochemical and Sharpies and things, are all incredibly, I love all of those smells.
Yeah.
I didn't sniff glue. The airplane glue didn't do anything for me. But that may not have been about smell for a lot of people. Give it up for Dr. Arielle Johnson.